Hello everyone, and welcome to today's webinar. Webinar is scheduled to begin at 2 o'clock. We're just past 2 o'clock right now, about 2:01. We're just going to give a few more minutes to give late attendees a chance to join. So we'll be starting shortly. Within the next 3 or 4 minutes, we'll be starting. I appreciate your patience. I think we can go ahead and get started. We are recording this webinar so that if there are latecomers, we will be able to share the video with them afterwards. I'd like to welcome everyone to the webinar today. And just before I do begin, I just want to make sure that everyone can hear me correctly. My microphone's picking up my sound. You can hear my voice. It's nice and clear. If I can just have one of the panelists confirm that broadcast is coming through loud and clear.
Sounds good.
Loud and clear.
Okay, perfect. That's great. Thank you. And everybody can see the screen as well, nice and clear. Okay, perfect. All right then. Today's webinar is how to go from a 3D part to 2D pattern in minutes with 3D to 2D digital pattern making. My name is Ethan Donald, and I'll be your host and moderator today. I am the CEO of ExactFlat, and I'm delighted to be joined by a team of panelists and colleagues. Our live demo engineer, his name is Luke Naranski. This is an actual likeness of Luke. He dresses in an orange cape and a blue shirt, but he does good work, so we let him dress the way he wants to dress. Luke, welcome to the webinar today, and I look forward to working with you. Our topic today, as I mentioned, is how to go from a 3D part to a 2D pattern in minutes. We will be looking at a real world example. In fact, here's the actual prototype that was built based on what you're seeing today. This is a furniture manufacturer that will go nameless, but this is their prototyping studio. And they started with a digital model such as this, and they finished with 2D patterns. The 2D patterns we will be generating are going to be different from the patterns that you see in the screen. And this is for reasons of confidentiality. We don't want to give away too much about how they're actually making their product. While we're working today with a furniture model, I do want to make certain that everyone on the call realizes that this workflow applies to any 3D model that you might have. These are some of the types of products that our clients make, from aircraft interiors, automotive interiors, furniture, medical devices such as knee replacement, medical stents, even some things that are not listed here like facial reconstruction surgery. We do have clients that are making artificial organs and heart valves and things like that. They use our product to make scaffolding and generate patterns for scaffolding that they use to implant a matrix of stem cells and grow artificial organs. It's actually a very promising area of medicine. Pools, bags and equipment, footwear of all types, whether it be workwear, leisure wear, it doesn't matter what it is. We've got a lot of clients very successfully doing work in footwear, turbine blades, vehicle covers, paint protection film, Kevlar, carbon fiber, marine canvas. So there's a very broad spectrum of items. If it is a soft good and it can be modeled in 3D CAD, it is appropriate for use in this digital patterning workflow. There is another element here which we're not going to cover today, which is 3D scanning. If you don't have a 3D model, you can scan your part and then go through the 3D to 2D workflow. But that's a topic for a different day. In fact, if anyone's interested, we just did a webinar with colleagues over at Peel 3D, and we showed that workflow on an automotive headrest. The workflow that we're going to be showing today, we're going to be isolating down to the core workflow steps. There are more elements that you can add to this. For example, if you want to do technical documentation, or if you want to create nests or multiple nests for that matter, those are elements that we will not be covering today. We're going to be sticking to the core workflow in the interest of time. The core workflow is very simple. You start with a 3D model. We're going to be creating pattern pieces from the faces on the 3D model. Luke is going to show you how to flatten those pieces, add seams and notches, and then create an export file that you can use to cut on whatever cutting machine that you might have. We'll be giving some emphasis to what we call the big 5 best practices. And the first one starts with modeling. What's a good model for pattern making? So we're going to be not explicitly talking about the modeling process. We're just going to be talking about what a good model is. And my colleague Luke will make some of those, we'll call out some of the attention to the details in the model as we go through the live demo. What makes a good mesh and how to create one, how to use material properties for flattening accuracy, how to add seams if they were sewing operations. So this is literally visualizing the way that you'd sew the parts together. That's the way we'll be adding seams with a beginning and an end and a direction. And then lastly, how to save time with cutter profiles. We'll be weaving this into the conversation. A little bit of housekeeping rules, not rules, pardon me, housekeeping items. We are recording the webinar today, so if you want to go back and review, or if you have colleagues, we'll be making a recording available. The webinar is in listen-only mode. If you want to ask questions, there is a question feature on the panel on the side. If you just look at your webinar tab, it's about midway down through the bottom questions. You can ask questions in there, and I have colleagues standing by that will answer the questions as we're going through the webinar. The last thing is we're going to be, from a time perspective, about 45 to 60 minutes. We'll certainly have you back at your regular job within the hour, perhaps even a little bit sooner, depending how your questions go. I would also like to point out that I'm joined by colleagues who are going to be on the panel today. Denny Libert from TexTempo is an SVP and co-founder. He has 25 years experience using shop floor control software solutions to transform manufacturing processes. His colleague Greg Hathcox, we're delighted that Greg can join us as well. He's also an SVP and co-founder of TexTempo, and he has 25 years experience implementing factory floor best practices in textiles, composites, furniture, and automotive. And from ExactFlat, we're also joined by Mark Jewell, VP of Product Solutions at ExactFlat, and he is one of the pioneers in the 3D to 2D digital pattern making space. He led the team that wrote the first 3D to 2D software many years ago. He led the team that wrote the 3D to 2D software for automotive dashboards and molds, and we're happy to have him today. And he's been one of the pioneering proponents of 3D scanning and the scan to pattern workflow as well. Of course, I mentioned that I will be handing over this demonstration to my colleague, Luke Naransky. Luke is a lead programmer and developer, and Luke is one of the foremost experts in 3D to 2D. He has seen more models, flattened more models, worked with such a wide spectrum of customers. We're very happy to have Luke's expertise and his knowledge to be represented here in the workflow today. And I will be handing now the presentation over to Luke, and we're going to give you a live demo of the process. So just give me a moment. I will change presenters.
So thank you, Eaton, for that introduction. Today we're going to be looking at this model here. This is a chair, and I believe Eaton showed a couple screenshots of the finished product. So we're going to be going through the steps required to flatten this chair. Before I dive into that, though, we're going to look at the construction of this chair, specifically the way it was created. There's a couple best practices that are used when we try to create different geometries for use with ExactFlat. There's lots of different ways that we can create a chair like this, but what we really want to do is, first and foremost, we need to think about how this chair is going to be sewn together. So the placement of different seams. With ExactFlat, seams are generated on Solidworks edges. So if we look at this model here, we can see we have our different pattern pieces. They're all color-coded. We've got our seat piece right down here. We've got our sides in different colors here. We've got our back panels yellow. And we can see that we've split these all up exactly where we want our seams to go. So for this particular chair, our seams are typically located on the radii of the construction of the chair. So this was a very deliberate design intent. We split this model up so we had edges exactly where we wanted our seams to go. So this is probably the most important thing that you need to consider when using ExactFlat. Beyond that, we want to try to make sure that we are minimizing the number of faces that we are using to create our model, and we want to try to minimize the number of edges that we have in our model. The more edges and faces you have, it's going to complicate your process. You can still flatten it, it's not a problem. It just may take a little bit longer. So if you have the ability, the option to generate your geometry with a minimized set of faces, that is definitely the best way to do it. So we'll jump into the process now. The entry point into ExactFlat is the piece creator. So once we click this button here, the piece creator is going to open, and we now have the ability to select faces. Internally, as we select our faces here, ExactFlat is going to use the SolidWorks knit surface feature to knit and sew all of these faces together into a single surface body. And ultimately, it's the surface body that is going to be flattened by ExactFlat. As we select our faces, we can see this little red arrow emanating from the pattern pieces. This is used to indicate the facing up direction of the pattern piece. So if you were to lay this flat piece of material down on your cutting table, that red arrow would be pointing up towards the ceiling. Depending on the methods used to construct your geometry, the facing up direction or the natural facing up direction may be reversed from what your intent is, as is the case here. The back side of the material is the facing up. If that's the case, we can just click the arrow to reverse the orientation of the pattern piece. For this part, because of the way it was constructed, every single piece is going to be recognized as reversed. So I'm going to change my default piece orientation over here from normal to flipped, and now ExactFlat is automatically going to flip every single piece for me as I create it. After I've selected my pieces, I can click the Create Piece button here, and that is going to insert my new piece into the Piece Manager. As I select additional pieces here, we can see that my face normal is now correct. We see the new faces appearing here, and ExactFlat automatically creates a new unique name. We can rename or assign our own names to these different pieces here. So if we don't want to use the automatic names, we can give the pieces our own names. So for this piece here, it might be more beneficial to call this Seat. So I'm going to call this Seat and click the Create Piece button. We can go back and we can rename pieces that have already been created. So for this one here, I'm going to rename it to Backrest. I will continue on creating the remainder of the pieces. So this will be, I'll call this Inside Right. I'm going to call this one Inside Left. And then we'll do the same thing for these pieces here. So now that all of our pieces have been created, we'll go ahead and click the OK button, and the piece creator process is finished. From here, we can examine our model, make sure that we don't have any unintentional holes or gaps. If we did forget to select a face, or if we forgot to add a piece, we can simply open up the piece creator again, and we can add whichever piece we forgot. If we forgot to select a face, or if we included a face in a part that isn't supposed to be there, we can simply select our piece from the piece manager, and we can edit the piece to either add the missing face or remove the face, either by deleting it from here or selecting the new face from the document. Once we are done with the piece creator, we can then go ahead and start the flattening process. And this is going to launch a multi-part process. First, we are requesting a mesh from Solidworks, and that is what we are going to be using for the flattening process. The next step is we are going to assign a material to our pattern pieces. Materials are very important in ExactFlat. They combine multiple different multiple informations pertaining to the flattening workflow. So probably the most important would be the mechanical properties of the material. So later on, when we finish our flattening process, we actually use the warp and weft of the material, the Young's modulus in the warp, weft, and bias direction to help us optimize the shape of the pattern piece. So it's important to pick a material close to what you're working with. We do recognize we only have a limited selection of materials in our sample material list here. However, we do have a process in place where you can have your own material measured, analyzed, and you can have your own material inserted into the database. So we can assign the exact same material to all pattern pieces, or if we are working with multiple materials in our part, we can select one or two or more pieces down here, and we can assign different materials to different pattern pieces. For the purpose of this demo though, I'm going to assign a single material to every single pattern piece. So I will just go ahead and click OK here, and we will carry on with the flattening process. Once we have finished the initial conversion process, we are still in model view. So now we can switch over to our pattern view, and this is where we can view our initial unoptimized 2D flat pattern. So the shapes that we see here, they're not optimized yet. They're not representative of the final optimized pattern pieces. So for that reason, we are immediately going to go into the flattener, and we are going to finish the flattening process. There's quite a few controls over here. We're not going to go over absolutely every single one, but I will say we do have some highlight controls over here on the right. These will allow us to turn on or off different highlights, such as the mesh triangulation. Over on the left, we have our flattening controls. This group of icons here are what we call our pre-flatteners, and these are the algorithms used to take the 3D shape and give us some kind of 2D unoptimized flat pattern. And over here, we have our remesher tools. We will be using one of these to simplify the mesh that we see here. And then lastly, we have our optimize tool. This is the second stage of our flattener, and this is what will relax the pattern pieces to minimize the average energy density to as close to 0 as possible. So the first thing we're going to do here is we are going to use our uniform remesher. This is going to analyze the curvature of the mesh, and it's going to replace it with a new unique mesh that is simpler in terms of triangle shape, size, and density. After we've done that, we are just going to use one of our pre-flatteners. I'm going to use our pelt pre-flattener, and this is going to help fix any kinds of folds or wrinkles that may have been generated during the initial flattening process after remeshing. And lastly, we are going to use our optimize tool here, and this is going to use the mechanical properties of the material to relax the pattern pieces to give us an average energy density as close to 0 as possible. So already after a few seconds, our first 4 pieces are done optimizing, and our last 2 are just finishing up right now. So the optimization process should be complete in just a few moments. We do use color to represent the quality or the accuracy of the pattern too. So as we look at our pattern piece here, before optimizing, we had quite a few rainbow colors. We had cyan, we had green, yellow, red, and all the colors in between. After optimizing though, we can see not only has the shape been relaxed, we have much more recognizable shapes, but the colors have been changed as well. So as we look at this, we see a lot of white and we see a bit of cyan. So with ExactFlat, white represents no strain. If your pattern piece is perfectly white, that means you have the perfect pattern, there's no strain on it. And as you move through the spectrum, cyan represents up to 5% strain, green is up to 10%, yellow is up to 15%, and red is up to 20% or more. So after optimization, you want to see most of your pattern pieces white, and depending on your material, the characteristics of it, how it can handle different strain loads, we have under 5% strain here, so depending on your material, this would be totally fine. So after flattening, we're going to go ahead and click the OK button, and this is going to update the planar surfaces in Solidworks with the results of our flattening operation here. So as soon as this is done, we're going to see our pattern pieces update to our optimized flattened patterns. So these already look much better. After flattening, it's very apparent that our pattern pieces just come in arrayed across the x-axis. They're in no particular order here. So before we start adding our patterning information, our seams, our hems, our hardware, and markings, it's best to orient your pattern pieces and put them into a layout that makes sense to understand how they're going to be sewn together. So to do this, we are going to use our Move Pieces tool. The Move Pieces tool is basically just an automation for the SolidWorks Move Copy Body feature, and it just allows you to very easily drag and drop your pattern pieces. So we can see the gray highlight here of where our pattern piece is going to go, and when I release my mouse button, it drops the pattern piece there, and it just automates the process of creating the Move Copy Body. We can also rotate our pieces using the exact same method. So I'll turn on rotation mode. And now when I click and hold on my pattern piece, we can see it rotating on the spot. So we can rotate this into whatever orientation we want. We also have some specialty alignment tools here. So if you have an edge on your pattern piece that is supposed to be perfectly vertical or perfectly horizontal, we can use the alignment tools. We can do both horizontal alignment as well as vertical alignment. So for these pattern pieces here, I know this edge is supposed to be the left-hand edge of the back panel. So I make sure I have my left edge highlighted, and when I click and hold on that piece, it's going to automatically rotate my piece, so that particular edge is perfectly vertical. I can use this to my advantage to help me rebuild the pattern. Our last tool is our Find tool. So this is going to help us find neighboring pattern pieces. So I'm going to change my offset here. It's set to 10 millimeters. I'm going to change this to 100 millimeters. I want to give myself lots of space. And I can use this find tool to help me find neighboring pattern pieces. So I'm just clicking and holding on the edge here. And when I do that, ExactFlat automatically finds the neighboring pattern piece for us. I'll repeat the process on the remainder of the pattern pieces, and this is going to help orient all of our pattern pieces and bring them together in a way that makes sense so we know exactly how they sew together. And then this piece, it would attach to these edges right here. This is the seat portion. So I know this piece goes up here with the backrest. So instead, I'm just going to use my alignment tool. I'm going to align it so that edge is perfectly horizontal. And I'm just going to manually drag it up here. So now that my pattern pieces have been aligned, I can start the process of adding our pattern information. I will start by adding some seams to the pattern piece. I'm not going to add seams to every single edge. That would take quite a while. So instead, I'm just going to add seams to a couple edges here. So I'll start with the back of the pattern, or the back panel right here. We want to make sure that we think of our seams as complete individual sewing operations. So if we were to sew this together, we would, for these two pieces here, we'd probably start down at the bottom and we'd sew all the way up to the very top. So we want to make sure we select our edges in that same order. So to begin, we're going to open up the seam PMP here. And now we can start to select edges. So we want to make sure we're starting at the very bottom. This particular model does have some fairly narrow edges. We want to make sure we're picking the very bottom narrow edge. And when we select that edge, we can see it's been added to our first selection box. ExactFlat has automatically found and detected the neighboring edge for us. There's a bit more information being displayed here, and we'll talk about that once I finish my seam selection. So I'm going to finish selecting my edges here. We've got our next one, and then our last seam is right up here. So as we examine the seam here, we can see we've got our green dots down here. These represent the start of the seam, and we can see our red dots up here. These represent the end of the seam. We want to make sure that both the green dots align and that both the red dots align. The reasons for this is as we start to add things like notches, if one side of our seam is reversed, then our notches may not align. So if that is the case, if one side of the seam is reversed, we do have these options right here to reverse the direction of the seam. So you can do this on whichever side is reversed. Just click that box and it's going to flip the orientation of the seam. So now we can see it was correct before. I've artificially reversed the direction, so now they're incorrect. But as we toggle that, we can see the orientation of the seam is being reversed. As we scroll down in the PMP, we come to our seam type, and this is where we can choose how much material is being added to our seam. Most of the data here is the default data that comes as part of our demo database. However, you can add your own custom seam types using our ExactFlat database manager. So you can customize, create your own custom seam types that are used in your own organization to meet whatever needs you may have. As we change our seam type here, we'll notice that the amount of material being added to our seam is changing. I'll zoom in to make it a little easier to see. So right now we're at 6 millimeter. If I change that to 8 millimeter, we can see additional material has been added. And furthermore, if I change that to 10 millimeter, we have even more material. So you can customize how much material is being added to allow for sewing of your parts together. So we scroll down a little bit more. We come to the notch chain option, and this is where we can create a chain of notches along the edge of our pattern piece. These don't necessarily have to be notched out using a cutting tool. You can simply use a pen tool to put them on, and you can treat them as actual notches, or you can treat them as simple alignment markings. It's totally up to you. As we turn on the notch chain tool, we are asked to pick a notch type. We will just stick to our 1/4 inch V notch here and click OK. And ExactFlat will automatically array some notches on both sides of our seam for us. We can create notches a couple different ways. We can either specify the number of notches we want arrayed across our seam, or we can specify the distance at which they are spaced. So if we change the spacing, we can tell ExactFlat to place a notch every 100 millimeters or so. And as we change that number, it's going to just place a notch at that set interval. So for the purpose of this demo, I'm going to change this back to count, and we're going to keep it at 3 notches across our seam. We'll go ahead, click OK, and this will finish up the seam creation. It's important to note that after we close the PMP, the edges are still selected. So because we have edges selected here, if we immediately open up the PMP again, this will bring us back into edit mode, and this will allow us to add any additional faces that we may have forgotten. So as a best practice, what I recommend when you finish creating a seam, just click somewhere off in the blank white space here and to deselect your edges. That way, the next time you open up the CMPMP, it's being opened up in create mode. So we'll finish adding a few more seams here. I'll pick these edges right here. And we can see ExactFlat has once again automatically found our neighboring pattern pieces for us. This time we automatically have our notches being applied, and if we scroll down, we'll notice that our seam type is set to 10mm join. That's because ExactFlat automatically remembers the settings that were last used, which makes creating seams really easy. All you pretty much have to do is open up the seam PMP and then select the edges that you want to create your seam along, and ExactFlat will remember the settings that were previously used, which means you can just close the PMP. Hems are pretty much created exactly the same way. The only difference between a seam and a hem is with a hem, you're typically not sewing it to another pattern piece, you're typically sewing that to itself. So for the bottom down here, if we wanted to add something like a pocket for a drawstring, we can do that using a hem. So we will open up the hem tool. And as I start selecting my edges, ExactFlat will apply a hem to that. Just like with seams, we have different hem types, and just like with seams, you can customize the different hem types available to you using the ExactFlat database manager. So as I change my hem type here, we can see the amount of material being added, updating in real time. Just like seams, we can specify notch chains, and again, these can be notched out or they can be penned on for alignment markings. For this particular project, I'm going to turn the notch chain off, and we're just going to click OK to accept our changes. So I can repeat the process over here. This time I'm going to pre-select my edge, and when I open up the hem PMP, ExactFlat automatically applies that hem to the selected edge. Once you've finished adding all your seams and hems, we can then move on to things like hardware and markings. The important takeaway for hardware and markings are that these are just 2 different mechanisms that allow you to map Solidworks sketches onto your pattern, which will ultimately be exported to a DXF. From an ExactFlat point of view, the only difference between the two is hardware typically represents a physical piece of hardware, such as a snap or a buckle, or a tie down, whereas a marking is typically used for something more along the lines of assembly instructions or reference markings. So if you wanted to pen on, for instance, a sew line or a reference line to mark the location of where a piece of hardware should be installed, you could use a marking for that. For this chair here, I'll demonstrate 2 different techniques that we can add hardware and markings. For this piece here, we're going to add a couple points here that may represent the location of buttons, decorative buttons that may be sewn into the back of the chair. So for this workflow, I'm going to show you our 2D pattern workflow. In this case, I'm just going to click on the piece and create an in-context sketch. And then for things like buttons, these are usually measured as a quantity, so you might add 5 or 6 buttons depending on your product. So because they're a quantity-based item, we typically use points to represent these. So I'm just going to put a point on my part everywhere I might want a button to be. And we're going to remember that as we finish our pattern, when we create our DXF, these points are going to be exported to the DXF. So we've created our sketch. We have 8 point entities on there. And now we are going to use the ExactFlat hardware tool to map this sketch to the pattern piece. So when we export this pattern piece to a DXF, these points will be included. As we open up the hardware tool, we can see the sketch has automatically been selected. The pattern piece mapping has already been selected because this was an in-context sketch. So all we have to do is scroll down to hardware properties, click the select hardware button, and then we can choose our desired hardware type from the table. Just like seams and hems, all of these hardware types are defined in our database, and you can add, remove any hardware type that you want using the ExactFlat database manager. So we'll go ahead and select button here, click OK, click OK. And now our sketch has turned to a solid color, and that tells us that this sketch has been mapped to the pattern piece. If it's easier, you can add your hardware and markings in 3D. To do that, we click the View Model button to go back to our 3D reference model. And because we're now working in 3D, we want to make sure that we are going to be using a 3D sketch. So for this part here, let's say that we wanted to add a reference sewing line for some kind of built-in drawstring pocket. Maybe this is removable cover. We can do that. We're going to go ahead and create a sketch. So we switch over to the Sketch tab. We're going to click the down arrow, select 3D sketch, and now we are going to create a spline. Because this is going to be a reference line, it's best to use a spline for this. So we are going to click the down arrow here and go spline on surface. I'm just going to freehand draw a spline on. We could create this using any method available to you in Solidworks. So if it's easier to offset an edge, you can do that. If you wanted to fully dimension your sketch, you could do that as well. For the purpose of this demo, though, I'm just going to freehand draw my spline onto the surface. So it's not going to be very even, but it'll show the workflow nicely. So now we have our 3D sketch here. We're going to switch back to the ExactFlat Tools Command Manager. And now, first we showed hardware. We're going to show markings. They're pretty much functionally equivalent. They just allow you to transfer sketch information from your pattern to the DXF. So we'll select markings this time. Because our sketch was already selected, it's already included in the selection PMP. For 3D to 2D markings, you always need to specify the model piece mapping. ExactFlat won't automatically determine that for you. So we just select the piece here that we want to apply the marking to, and it appears in the box. We will scroll down. We're going to select our marking type. Because there's no piece of hardware associated to this, if all you're interested in is the sketch on your DXF, then it doesn't really matter what you choose here. However, if you're using our drawing tools and you place any kind of hardware or marking table on the drawing, then these names will appear in the drawing. So you can use these to help with your documentation process, but from a functionality point of view, it doesn't really matter which one you pick here. So I'm just going to pick fold line here and click OK. And click OK, and now that sketch has been mapped to our 2D pattern piece. So we'll go back to our 2D pattern view, and there's our sketch mapped onto the 2D pattern piece. Once we've finished adding our hardware and markings, we can now go ahead and set up our marker. ExactFlat does offer both manual nesting and automatic nesting. By default, the layout of our marker pieces is exactly what we see in the 2D pattern view. For a manual nesting workflow, we can simply drag and drop the pieces wherever we want. We can right-click on the pieces and we can rotate the pieces however we want. And we'll notice if we drag our pieces off the marker, they turn orange and it won't allow us to place them there. If your marker is really, really crowded and you just need to make room for another piece, you can just press escape and that will drop your pattern piece wherever it may be. If we wanted to go to an automatic nesting point of view, we do have automatic nesting. We do use the Fraunhofer nesting algorithms to do that, and we can do automatic nesting by clicking the nest button. Before we do that, we're going to set up some piece constraints here. So we can constrain how pieces are allowed to rotate on the marker, and this is going to depend entirely on the type of product that you're creating in your workflow. If you have a printed piece of material like a stripe or a plaid, you may want to constrain the rotation of the pattern pieces so they align to the constraint. So what we can do is we can select our pattern pieces and we can change the rotation increment. So if we wanted to constrain them to 90-degree increments, we just set our increment to 90 degree, and now our pattern pieces should align to the plaid pattern of our material. We can also specify a rotation tolerance. This is a plus or minus factor, so if there's a little bit of wiggle room with how your pieces are allowed to rotate, you can set your rotation tolerance, and this will help increase the efficiency of the nest. For the purpose of this demo, though, I'm going to allow any rotation, so I'm going to set that back to 0. We can also specify the number or the quantity of the pattern pieces that we want to place. So over here, we can change our multiples. For the purpose of this demo, I'm going to change our parent multiple to 10, and we're going to have 10 copies of each pattern piece on our marker. So we'll go ahead and click OK. We can now see that we have 10 pieces available. We have 9 remaining in our inventory. So I'm going to select our pieces here and add the remaining copies of the pieces to our inventory. So now we have 10 copies of each piece on our marker. For automatic nesting, I'll click the nest button here. There's only 2 controls that we really have to adjust in the automatic nesting interface. We can adjust our target yield. This is our target efficiency for the nest. Unless you're nesting squares and rectangles, you're probably not going to get to 100%. So usually it's better to adjust the time. You can set this to whatever you want, and your choice here will really depend on your time available and the price of the material you're working with. Some materials can be extremely expensive, so every millimeter counts. In that case, you might want to set this fairly high, 8 hours or so, just let it run overnight. For the purpose of this demo though, I'm going to leave it at 1 minute. I'm just going to click the nest button, and very quickly we are going to see Fraunhofer take over, and it's nesting all of our pieces for us. It's packing them in as tightly as possible. So we can let this run. I'm just going to hit the stop button. I'm going to accept the result exactly as we have it here. So I'll click the accept button, and now we can close the automatic nesting interface. Once we are ready, once we're happy with our pattern and we are ready to export it as a DXF, we can click the export button here, and this is going to open up our export profile manager. From here, we have a couple options. We have our DXFs are all exported based on different profiles. And really, profiles are just different named collections of layer names and layer colors. So if we look at something like Eastman Easy Cut, we can see all the different entities that are going to be exported for this profile. We can see, for instance, our pattern perimeter and our internal perimeters. They're going to the cut me layer, and the color of that layer is red. If we compare this to something like an Onometrics profile, again, for this profile, we're exporting both the internal perimeters and the pattern profile or pattern perimeter entities, and they're going to the cut one layer. So the only difference between the profiles is the entities that are being exported, such as cut line, sew line, grain line, hardware, and markings. The layer names are changing, and the color of the layer is changing. So this allows you to customize your DXF. So when you import it into your cutting system or your downstream process, whatever that piece of software may be can correctly identify all the different entities based off of the layer name and the color of the layer. So once you've picked your profile, just click the export button, and then you can pick a place to save your DXF, and you're done. So that's about it for the ExactFlat workflow. At this point, I'll hand it back over to you, Eaton.
All right, Luke, that was a fantastic demo. Thank you for taking us through that. That was fantastic. So I just want to do a quick process recap. We did the live demo, and now we are going to just talk about some of the best practices that Luke had shown there. We did cover what's a good model. We did cover what's a good mesh and how to create one. We did cover how to use material properties, how to add seams as if they're sewing operations, and how to save time with cutter profiles. I'm just going to remind you that this is actually a production part. There we go. This is actually a production part. What you're seeing right now is a 3D model to 2D patterns in minutes. That file that Luke produced could be cut and it could be placed on the furniture stump, and you could have a prototype within a very short period of time. The other thing that Luke just alluded to is you could actually have many more pattern divisions than what was shown here in the demonstration. So if you're looking at optimizing your part from an aesthetic or from a sewing operations or from a manufacturing time perspective, it gives you tremendous flexibility to have a variety of pattern configurations that suit what you are trying to do. So Luke, I thank you for that, and you have lived up to your Superman moniker, so that is great. I want to just skip ahead here now to audience questions. And actually, there's 3 things I want to talk about before we get into audience questions. And what I would ask, if you do have questions, we've already had some, please enter them into the question feature on the panel on your webinar side, and we will get to them as best we can. So when we give demonstrations like this, Luke did cover a lot of ground. In fact, he gave you some bonus content there in how to create a nest and some of the parameters of our nesting. The beauty of our nesting is it's connected to the pattern making, which is connected to design. So you get real-time dynamic nesting. You don't have to ship it off to a different place to get the immediate feedback about what the nest is going to cost. You can do your configurations, your design iterations, and very quickly come to some determination. So the first question that we get all the time is, can I learn it? And I'm going to ask one of our panelists here to make a comment on this. So Gene, could you comment on the
No, I've got it. Can I learn it? And
yeah, can I learn it? Yeah.
Right. And how long does it take? So if you're an experienced SolidWorks user, it usually takes about 4 hours to learn, which seems phenomenal. And if you don't have a SolidWorks user, there are plenty of people in the marketplace that do have experience, and they're easy to find. To go further, what is SolidWorks? Well, SolidWorks is part of Dassault, and it's the #1 3D CAD platform that's out there in the industry that we see. A lot of the furniture companies that we talk to, they use SolidWorks, and so that would be a perfect fit. Another question that we get and is that, how does it compare? As far as competitors out there, how does ExactFlat compare? Sometimes our competitors' products can take up to a year to learn. And then to find trained users, there are far more SolidWorks users out there than most any other CAD software. And again, just adding the ExactFlat takes as little as 4 hours to learn. I'll turn that back over to you, Eden.
All right, thanks, Gene. And I think that's a relevant point that you brought up, that for experienced SolidWorks users, this is a mere sideways step, and you can learn it very easily and very quickly. In fact, we have people doing production work within the first week of their learning the product, and we're talking real production work. Competitors do take a long time to learn. We're not going to name them, but they can take up to, as Gene said, up to a year. And then if you lose that person, you are kind of starting at ground zero again. So it is a risky proposition, and this is a fair concern. We get this question a lot, and we would encourage everyone considering the move to digital patterning to satisfy themselves that they're picking the platform that will allow them the greatest amount of business continuity. Okay, second question is, does it work? I'm going to hand this question to Greg from TexTempo. Could you maybe offer the audience some insights into the does it work question?
Sure, thanks, Eden. When people ask, does it work, they usually are talking about two different areas. First of all, is it accurate? And secondly, is it fast enough to make a difference in my business? So regarding accuracy, we can tell you anything, but what we would recommend is that we go through one of your products through a structured evaluation process. And if you are interested in that, just let us know and we can set that up. But it's better to actually show you the accuracy in respect instead of just telling you. So the other part is speed. And this is one of the great benefits, is allowing you to get products developed faster. And it really depends on your current processes. Some people have automation already. Some people are starting from very manual processes. So our experience with our current clients is it can be anywhere from 2 to 20 times the speed of the current process. So that is a huge factor when people look at investing in this kind of automation.
Thanks, Greg. And I think just to echo that point, the speed increases are meaningful. Nobody wants to make an investment and change a process for a modest increase in productivity. And we think that we can confidently say to prospects looking at change in their workflow that the speed increments are very meaningful. With respect to the accuracy, I'll just add a little bit to what Greg had to say. And by the way, Greg and Gene are both manufacturing experts. They have seen hundreds of shop floors and processes, and they're very knowledgeable. And I think, I'm very happy to have you guys on the call here. So with respect to accuracy, there's an easy test you can do. You can take an existing pattern, you can run it through this process, you can superimpose the new patterns on the old patterns, and you can see the accuracy difference. There's other tests. You can measure seam length in 3D, seam length in 2D. You can measure surface area in 3D, surface area in 2D. Those are very quick feedback items that let you know. Luke mentioned the color coding system for the sag and strain. That will give you feedback in terms of where relief cuts or darts need to be placed. That's another variable that would affect your accuracy in terms of how things are made. Rather than guessing as to where those are, you can actually see them. You can see where the sag is, or where you're going to have some puckering, or maybe where the fabric is going to stretch tight. So, but generally speaking, to echo Greg's comments, it does come down to the two concerns: accuracy and speed. We can say from general terms that the accuracy is production level accuracy. That means like in the 99.5 and above percent. In fact, we've just had some recent clients that have done tests where 99.7, 99.8. And for fabrics, that's generally a perfect pattern. You're not going to get manual pattern making to be much better than that, if at all. If you're using ExactFlat for other things, like for metals or for woods, you have options in terms of how you set your flattening planes to use the outer surface, the mid plane, or the inner surface. Those are all things you can tune. Other things with respect to accuracy, Luke showed a number of pre-flatteners. One of the good things about it is we have a lot of controls, a lot of different pre-flatteners depending on your geometry, whether it's spherical, double curvature, more developable surfaces, that you can tune your accuracy to get it right. We had a question that came in with respect to footwear. Many clients using it in footwear, even though that's not the emphasis in this particular presentation. It is, absolutely one of the use cases where we have very happy customers. Now, the last question I'm going to put over to Mark. Mark, if you can just activate your microphone. Last question that people ask in terms of their concerns is, can I afford it? So, Mark, can you talk a little bit about that, please?
Absolutely. So, compared to the current software that's available in the marketplace for doing this type of work, as you can see, everything's incorporated kind of using Solidworks as a hub. If you were to buy these pieces all individually, you'd be into the $30,000-$40,000, or 4 to 5 times the price that our product is costing. So the affordability, basically, if you look at the productivity returns that you're getting from the software, and the fact that our software is priced probably in the very lower end of what's available out in the marketplace, I'd say it's definitely affordable. And I believe, Eaton, that there's going to be a promotion run to the people that were in on the webinar today. That'll be going out via email, hopefully, I guess, tomorrow.
Yes, that is correct. We do have a webinar special for people, and I'll just add a little bit to your comments, Mark. Right. So the question, we get the question a lot: can I afford it? And the answer is really it depends. If you're a high volume pattern shop, that means you do a lot of patterns, right? Or if you have requirements to improve your speed, or if you make very expensive parts. We talked about some of the things that we're doing. We know in furniture, for example, it used to be okay that you had 10 styles and 1,000 customers. Now you need 1,000 styles for 10 customers because everybody wants a custom one-off job. So if you look at the movement from more mass uniform product to more unique product by channel and by customer, then the affordability becomes much, much more in favor of those types of scenarios. The ROI certainly is better if you have high volume and expensive parts. But we do have a structured way for you to assess this, right? And if you're interested, you can just email us on. We'll pass on the details about how we can do that to you. But just to put some numbers here, because I know people are going to want numbers. So our entry-level flattener is about $7,000, and for the full SolidWorks product, you're looking between $12,000 to $20,000 if you include nesting. That compares to, as Mark said, between $30,000 and $40,000 for competitive products. And we do have financing available, so we don't want anyone to be shut out for affordability concerns. Now, those are the top 3 questions that we do get. If you guys have more questions, and I do see there is a question here. There's a couple questions here. So Luke, first of all, there's a question: can we quickly see the costing features, feature based on the marker efficiency? I don't know if you've already closed it down, Luke. Is it still available to be seen, or have you closed it down already?
No, I haven't closed it down. Honestly, my demo database isn't really set up for costing, but we do report basic costing for material usage and hardware only. So that's basically in the form of, we tell you how efficient your nest is, how much material has been used, and if you have assigned a valid price to that particular material, we will give you a rough raw materials usage cost for that material.
Yeah, the benefit of it is it's instant. We hear that the nesting operation is often separated from the design operation, and therefore it takes a little bit longer to get a cost, or to run a nest. There's many more steps involved. Here, the design engineer or the pattern engineer can do it, and they can get an immediate feedback. That's particularly useful if you're looking at scenarios where you've got one pattern design and you've got another pattern design. Maybe you've cut one into more pieces, so that piece will have much more sewing operations, but the yield on the nest may be much better. And so you can compare and contrast that very quickly. Real-time dynamic nesting, as opposed to nesting that is sent to a separate department that takes a while to come back. And the other question here is about fit, and I'm assuming fit then relates back to accuracy. So I'll talk a little bit more about accuracy and some of the things that we do differently. So Luke had mentioned we start with 3D geometry. Your 3D geometry must be an accurate reflection of your pattern pieces. When we have the 3D geometry, we create a nest. The nest, not a nest, a mesh. The mesh has certain features that make it better suited for doing the computations. So if you look at this mesh here, we have meshing tools that have more or less equilateral triangles. The change in size between the triangles is gradual, and we can adapt the size or we can keep them uniform. These meshing tools lead to better results because these are computational algorithms that have to work on the mesh, and to the extent that the mesh is predisposed to those computational algorithms, it's better. The next thing is material properties. We mentioned that we do have a partner we work with, Manufacturing Solutions, to test your material. They'll put it on a machine, they'll pull the fabric in different directions, they'll write a report. You'll get an engineering report. It's very inexpensive. It's in the neighborhood of $25 or $30 per test, which we think is really quite reasonable. Other things that would affect the fit are the strain and sag feedback, which would give you feedback on where to put relief cuts, and the ability to use a variety of pre-flatteners to get to the right starting point patterns for optimization. I hope that, Jim, if that answers your question, I hope that does. If you have any more questions, please feel free to email us, and we're happy to take them there. Can it integrate shrinkage factors as a buffer needed for fit? So that was your question with respect to fit. Maybe let me address that again. So shrinkage factors. So you must understand that ExactFlat works with input. That input has to be static. So if you've modeled your part, that's the patterns you're going to get. If there's a shrinkage factor, you have two choices. You can either shrink your model by a certain percentage, knowing that you're going to have some strain in your part afterwards, or you can tune, or true as they say, the 2D pattern pieces after the fact. That's a strategy that many of our clients do. And if you want to know more about that, we can certainly talk more about that offline. That's a bit of the science meeting the engineering there. So can ExactFlat nest on leather where the high visibility parts would require less natural imperfections, or would that require a scan of the leather? So you're talking about, I'm going to actually hand this question to Luke. Luke, did you understand the question, or do I need to go over it again?
No, we're good.
Okay.
ExactFlat's materials for nesting are limited to rectangular pieces of material, so it's usually not very well suited for nesting on leather. Beyond that, we don't have any mechanisms for specifying the grading or the zones of the leather. So it would just nest any piece anywhere onto the leather that it could, without regard to the quality or the visual aesthetic of the leather. Typically for leather, the feedback I most often hear is that the surface of the leather is scanned using specialized hardware, and it's graded and zoned. So you mark the areas of imperfections where pieces can't be nested. You mark the different zones for the quality, where some pieces might be used for high visibility finish, whereas other pieces might be used for parts of your product that are not as critical. But unfortunately, ExactFlat doesn't have those controls. We don't specify the zone of the leather, and we're limited to rectangular pieces for nesting.
If I have patterns made by a supplier, can I import directly into the 2D portion of the software for production? Am I able to import .mdl files?
If Solidworks can open the file, then you can work with it so long as it is surface data. I'm not 100% sure on .mdl files. I'm just having a quick look now to see if that's in the Solidworks list. It's not a file format that I have heard of before, so I'm thinking
that might be Electra data type. Just jumping in there.
Okay. Yeah, I'm having a quick look here. I don't see it. If it's Electra data type, we probably can't work with it. But if you can export your part as a step file, then you can definitely bring that into Solidworks. And you can't go directly to the 2D workflow, but what you can do is using the piece creator, you're not limited only to 3D models. You can select and form pattern pieces from 2D planar pieces, and that will effectively skip the flattening workflow. It just goes straight into the 2D environment from there. So you still need to go through the piece creator, but you can bring them directly into the patterning environment afterwards. At that point, you can choose to add seams, hardware, markings, all that kind of stuff if you want. It really depends on the state of your pattern at that point. You can recreate it in ExactFlat, and then finally, you can bring it into the nesting component for nesting.
Okay, I have a question. While benchmarking your ExactFlat software, what have you noticed when comparing your software to DC3D, for example? Have you had customers switch from them to you? If so, what are the common feedback comments you hear associated with DC3D? I am not familiar that we've had anybody switch from DC3D. Luke, have you? Are you familiar with this at all?
No, I'm not very familiar with that software.
Yeah, so Derek, I would say that that's a question we could explore maybe offline. If you have questions, we could look at benchmarking on a part of yours specifically, and we'd be happy to take a deeper dive into it. But unfortunately, we don't have a better answer for your question right now. Another question, you mentioned roughly up to 20K for all the modules, full access. Would we need SOLIDWORKS prior to purchasing ExactFlat? That is correct. So ExactFlat is an add-in for SOLIDWORKS, and you would need a seat of SOLIDWORKS. And then the 20K version is the full version of ExactFlat with, you know, the flattening, pattern making, documentation, and nesting. It's in and around that. Don't quote me on that. You'll have to talk to Mark Jewell after this, but you're in the neighborhood on the 20K there. Next question. To the third decimal in inches, how accurate is the fit of one pattern next and between notches? What are the tolerances? So Luke, if you can talk about the way that we do the tolerances, the way that we do the notching, and specifically the indexing we do from 3D to 2D.
So when we do our flattening, we build an internal map based off of the 3D model of which edges are related to one another. So that's why when we go to create our seams, we only have to pick one side of the part. ExactFlat will automatically find and place the equivalent seam on the neighboring part. So that's the first part. We have automatic mapping of which edges are related. As we do our flattening, we're striving to minimize the average energy density. We want it so the pattern piece that we generate after flattening, you won't have to stretch it in any way to get it to fit onto the 3D shape. Similarly, we don't want any excess sag in there, so we don't want visual wrinkles or folds or fingers of material on the pattern piece. So as we approach no strain, that creates a pattern with a perimeter length that is pretty much identical to the 3D model. Depending on the type of geometry that you're working with, if you have double curvature in there, it's pretty much impossible to avoid stretch or strain or even a bit of sag every now and then. So there might be some fluctuations, but the important thing is that sewn edges, two edges that sew together, are typically preserved, and the error between the length of one sewn edge compared to its neighbor is usually very, very small. Usually the error that we experience is on the order of maybe 1 or 2 millimeters. So the notches that we generate are extremely close together. The amount of error in there is very small. We do have additional metrics that you can engage that will further minimize and reduce that error. However, it does so at the expense of increased strain on your pattern piece. So it will add more strain to the pattern piece to ensure that your perimeter lengths are the same. So if you're working with a material like a sheet steel that's going to be welded together, and you need to be absolutely certain that your two edges that are being welded together are the exact same length, you can use the no seam stretch feature of ExactFlat to help guarantee that your edges are going to be exactly the same length.
Yeah, and so thank you for that, Luke. And I'll just add a little bit of commentary with respect to the notches. Each of the vertice points that you see here is part of the index mapping. And when we put a notch on one side, it automatically is aligned to the other side, as Luke said. This is in stark contrast to the way that you do your notches in a 2D patterning program, such as the 2D patterning programs that are very popular that are sold with cutting tables and others, where you have to walk the pattern. No walking the pattern is necessary. The commentary is the notches align perfectly when sewn, and that leads to better quality finished products. And you get to that notch, perfectly aligned notches very quickly. As Luke said, you can specify by count or you can specify by spacing, and they are literally identical on one pattern piece to the next pattern piece. So if you want to explore that in a little bit more detail, we do have some videos on it, but you can also just email us after this. We'd be happy to set up a demonstration and talk through a little bit more detail about specifically how the notching is done. But I think you'll be very pleasantly surprised by the accuracy of the pattern pieces and the notches. Okay, we have another question. Can ExactFlat produce Velcro closures instead of sew seams? Luke, I'm going to hand this one to you as well.
Yeah, so that's just a design decision, and there's a number of different ways to do that. If you just wanted to add a flap of material onto one side of the piece that you would then sew some Velcro on, there's a couple different ways. You can either create a hem on one side of the piece and just sew your strip of Velcro to the hem, or you can create an asymmetrical seam. So when we showed the seam tools, we were seeing the exact same seam allowance being created on both the left and right hand side, but with an asymmetrical seam, you can specify a variable amount of material on either side. So for something like a piece of Velcro, you might want to specify no seam allowance on the left, but a 20mm seam allowance on the right, whatever amount of material you need for your piece of Velcro. So there's a couple of different ways you can do that, and it really depends on your established manufacturing processes and design processes, your documentation that you're producing. So whichever way you're currently doing it now, it can most likely be adapted to an ExactFlat workflow.
And again, I'll just reiterate for that question, you can email us and we can set up a time to go in depth on how you do an asymmetrical seam or whether you do a seam on one side. And Luke did demonstrate putting a sketch marking. That could be where you'd sew your Velcro one side of the Velcro piece and on the one side of the pattern piece, and then you use a hem or other technique on the other side. So yeah, feel free to let us know. Okay, another question. And this is not in furniture necessarily, but nevertheless, a footwear last is a very curvy asymmetrical object. How does the flattening represent the two different sides of the last in 2D form? So I know that we do have a lot of customers in footwear, and Luke, I'll hand this back to you as well. So the inside of the foot is a different geometry from the outside of the foot. And the question is, how does the flattening represent the two different sides in the 2D form? If I've got that wrong, Tony, pardon me, please go ahead and correct me in the question. But that's the question, Luke.
So the flattener simply flattens the 3D mesh that's given to it. So it's your responsibility to split up that mesh into however many pattern pieces you require. So if through your normal processes you normally create your shoes as two pieces of material, one for the left and right hand side of a foot, then you would split your part in half according to where you normally would have your seam line. That's obviously going to create only two pattern pieces, and they may be fairly strained, but that might be acceptable depending on the material that you're working with. Materials like leather, they don't really stretch all that much, so you may need to create additional pattern pieces. But if you're working with like a woven material, or if you're even knitting your shoes using like a 3D knitting process, then that might be fine for your process. So it really depends on your manufacturing techniques. For if you're only splitting it in half, obviously there's going to be quite a bit of double curvature there. So ExactFlat will expand it as best as it can, but for those types of shapes with only one split line down the center, usually there is quite a bit of strain in the pattern piece. So it really comes down to your existing workflow and how you would normally split it up. You would want to replicate that in the ExactFlat environment by splitting up your model first, and then ExactFlat would flatten it with those splits in mind and give you the patterns based off of your own design decisions. And as I'm sure Eaton would say, that's always something we can explore with you if you wanted to contact us. We could probably help you out and show you what the patterns would look like on one of your files.
And I'll just add to Luke's comment that oftentimes I'm not a footwear expert, so forgive me if I'm going a little astray here, but there's a single piece that wraps around the toe cap from the inside to the outside of the shoe, and that piece is a highly non-developable, and it's highly asymmetric. And in addition, it wraps around under the toe and under the foot, and it's got to have just the right amount, otherwise there's going to be some other issues in terms of like the functionality. And then there's the side pieces, as Luke said, individual side pieces. If they're one piece or they're two piece or they're split, oftentimes we see them split at the back. We have some experience in this, and we do have customers doing exactly what you're describing right now, and we'd be happy to show it to you live. So Tony, if you want to know a little more about this, I would say reach out to us. I'm just going to say that we're going to follow up with everybody, and there'll be contact information for all the panelists on this call, and you can reach out to us, and we'll be happy to show you, visually how this is. But as Luke said, this will come down to your specific design and your processes and how you want it to work for you. There's no one way here. There are multiple ways that you can achieve this goal. But I think you'll be pleasantly surprised at the degree to which we can give you an accurate result. I do thank everybody. This has been a pleasure to answer your questions and demonstrate the 3D to 2D digital pattern making workflow. It starts with a good model, and if you have a good model, then the part to pattern is typically minutes. And I will go back. I'll go back to our prototype here. This is the very first prototype produced, and the client was extremely happy. They did a little bit of truing and tuning on the model, and it was done. This typically took them anywhere from 3 to 6 weeks to get the patterns just perfect, and this happened in a matter of a day and a half. So if this is the kind of thing that you guys are interested in, we have some experts on the panel, Gene and Greg from TexTempo. They have a lifetime of experience working in the furniture sector and working with software this type, as well as processes. Both Mark and Luke from the ExactFlat team. We'd be happy to talk to you. And I will say that, let me just skip to the end here. We do have a next step that people can take. So we typically have a digital vision that we produce for people who are switching from manual to, or partially manual processes to fully digital processes. The first step was we'll review your current process. Second is we can help you develop a digital vision. That means a digital workflow based on your context. And then we can actually demonstrate it to you. And the demonstration will be, we'll take your part, we'll do something very similar to what we did in this webinar, and we'll send you the output that you can test for accuracy, test for speed, test for can I learn it, all those types of things. And this is a very fast way and a structured way that you can evaluate whether this is right for your business. Now, that's typically about 10 to 15 days, depending on the process we set up with the organization, and it's typically about $5,995 for consulting. We're making it available for free for all the attendees of this webinar. If you want to engage in a process like that, we will be sending a follow-up, and you can just express your interest to do so. I will repeat, it is free for all the attendees for this webinar, and we will help to establish a digital vision. And we do have the process experts, both at TexTempo and at ExactFlat. We'll be delighted to demonstrate this And I think you'll be pleasantly surprised at how quickly we can, just develop that vision for you. ExactFlat has been around for many years. It is used in many industries. About 50% of the automotive cars produced in the world, their dashboards are produced with ExactFlat. Furniture companies, composite companies, automotive companies, we feel that we've got a solution that people can have confidence in. With that, I'd like to thank the panelists. Luke, thank you for your demonstration. Excellent as always. Greg and Jean, thank you for your participation. And Mark, thank you as well. And I'll be closing the webinar. Everybody, hope that you have a great day.